excited for you guys to see what they've been able to achieve in the last 3 months. So please welcome to the stage Xavier from Embody.
All right. Hi, everyone. I'm Xavier, one of the co-founders of Embody. So here, I believe most of you have watched these movies, and that's what we believe robots should be like. And at the very minimum, we can teach them something. They can learn stuff, right? But in reality, these are the common robots, the common commercially available robots. I would say they are great at what they do, but the question I keep asking myself is that in this AI world, why have robots lag behind? Why? Because robots can't generalize. They are either trained or scripted, programmed to do exactly one thing in one environment. And changing even a small detail makes them useless. And data is scarce and expensive to collect. Right now, the robot dataset relies on very heavy teleoperation, remote control to collect data. And a great example is the open cross-embodiment dataset. That's quite famous. And it's collected across 18 months by 21 institutions. It's very expensive. And transfer learning doesn't work. Because as we train a model or train a robot to do some task, if we change to a different robot, a different hardware, it doesn't work. And even a camera angle change, like your eyes looking differently, then things will break. Plus, the current solutions are slow. Robot requires a minimum of 10 hertz to operate well, while current large language model and visual language model are just not that good. So generative AI has the potential to imbue robots with human-like capabilities. And people are trying really hard to bring generative AI to robots. Oh, an interesting thing, well, most of these humanoid robots are still remote control or teleoperated. But it's really hard to generalize with great accuracy. This is a great example, RT1 and RT2. These are the foundation models by Google DeepMind. And RT2, the best of the best, released like several months ago. And for the same task it was trained on, if you change the background, there's like about 25% of failure rate. If you change to a different environment, the failure rate is up to 50%. And the RT1 was fundamental. When you change to a different background, like the table color, the failure rate will be like 50%. And the problem is how to increase task-relevant data at scale with the best end user's experience to make robots smarter and better. Introducing Embody. We are dedicated to enabling internet-scale learning in robotics. How are we doing this? We're creating a unique end-to-end learning platform. We have a very easy interface to teach robot by just commanding it, or visual demonstration, or integrating to the existing stack. And the world model. What is a world model? The world model is given data a robot collected when we taught it to do something, and it'll go through the world model to generate and augment 100x the data by diffusion, and the foundation model for any robot embodiment. And all of these are not possible without the end-to-end data pipeline, which chain all these components together. No machine learning expertise or scientists needed. Here's how this works. Just teach a robot, collect the data, and the data will be automatically passed to the world model for augmentation in the cloud. We get 100x amount of data, and to do the fine-tuning and training of the foundation model, what do we get? A more capable robot. And what's amazing about this is that as the robot's more capable, it's even easier to train the robot, to teach a robot, and collect data. This is an example. This is a pharmaceutical robot in the hospital. What it does is that it's able to pick some pills, and that's the only thing it does. And what if we wanted to pick up something else, like a syringe, like mask, or scissors? Just integrate Embody to the stack and teach it, commanding it to pick up syringe or mask, and then a couple of times, all this data will be passed automatically to the cloud and get trained, and the robot will be more capable. And this is not limited to a single hardware. Any robot embodiment can do. All right, here's our team. Sebastian, our co-founder and CEO, right there. I always call him a genius, but he's too humble to take that. Yeah, physicist, roboticist, machine learning researcher, and that's me. We are close friends and teammates since the Google time, and we were managing Google Public DNS, the world's largest DNS resolver. We minimize latencies and protect the whole world DNS internet traffic. And robot time. I believe most of you guys haven't really seen a robot being taught to do something, so let's see if this works. I'm a little bit nervous here, because right now it's not scripted, not programmed, everything live, 100%. All right. Let's teach a robot to pick up the marker, right? Okay. Let me pull this up. Let me check the microphone, 1 sec. Good. Okay, I'm going to teach you how to pick up the marker on the desk. And as you can see, it's to your left. What do you think your first action should be?
My first action should be to move my gripper to the left to align with the marker.
You're close. You need to move just a tiny little bit to the left more.
I will adjust slightly more to the left to perfectly align with the marker.
You are actually right above it. Now, try to go down and pick it up from the table.
I will move down to the table and open my gripper to prepare for picking up the marker.
Okay, I think you are at position. Just close your hand and lift your arm.
Closing my gripper to grasp the marker.
All right, good job. Now release it.
Releasing the marker now.
All right, I just moved the marker to a slightly different location to your right. Can you try to pick it up again? Let's see.
Moving my gripper to the right to align with the new location of the marker.
Good position. Now try to go down and pick it up.
Moving down to the table to pick up the marker.
All right, good job. Now close your hand and lift your arm.
Closing my gripper to grasp the marker.
All right. As we teach a robot, every conversation, every action, they got passed to the cloud instantly for a continuous training. So I would love to pull up a AWS terminal here, but just that's the end-to-end part, which is very fascinating. And this is the Embody world model. I would like to show you a quick peek of what world model is like. As a robot collects data like that, for example, picking up a fork. And remember, when you change to a different background or environment, robot just doesn't know how to do it. So how to solve it? With Embody world model. By diffusion. What about office top? Or wood floor? Or a gold arm with blue floor? Or a carpet? With Embody world model, we can generate an unimaginable amount of data from just a single one. And one more thing, we are open sourcing our new cross-embodiment robot foundation model in coming weeks. It will be available on Hugging Face. Yeah, interesting thing. We talked to Clem, CEO of Hugging Face, last week, and they also just launched their robot division. And we think the advancement of technology in a space like robotics, it's not done by just one or two companies. It's across all the people and all the companies at every stack, every layer. And we hope we can improve this, push the boundary forward. And with Embody, we believe we can increase the efficiency of robotics training and data collection by 10x, with a limited potential for robot generalization. Yeah, robots are a $15 billion market, and each of them only has one job, and one job only. What if every robot could learn to do anything? But actually, in fact, robots should be a multi-trillion-dollar market, because they should be in our lives at anywhere, and actually, they can be. And we are racing to accelerate our research, engineering, and product efforts. We hope we can bring artificial general embodied intelligence a little bit closer to the world. All right, let's get in touch.